This is making client-server workers work. Call worker, call form in the real world. My name is John Baughman. I'm a consultant out in Hawaii. Got a little company called Byte Design Hawaii. Some of you may know me from previous summits. Like they said about, 10 years ago maybe, I made the announcement that I was retiring. Obviously, that didn't happen. Well, I did, but I'm still working with 4D. That's my main thing to do. Today we're going to talk about C object, dot notation, new object, worker process, call worker, call form, all working together. Okay? You've seen all the bits and pieces. Hopefully this will help you see how they can all work together. And quite frankly, I think these are some of the best commands that we've gotten, the most improvement we've gotten in a long time. I mean, you look back in years past, we went to Windows, we got client server, those were big deals. This ranks up there, I think. When you start working with these new commands, I think you'll agree. How many are already working with all these? Are all of you doing it? I got some of them, okay. Well, the big one is call worker, okay. The rest of them all kind of support there. In the demonstration, I'm going to show you where the light's shown in my head. I had a long-standing problem, a challenge of inter-client, inter-window communications in a scheduling system. Okay, this is an orthodontic office, a clinic, a front office, about 7 computers. And every computer has the schedule on their screen. You'll see that in a second, as many as 2 schedules on their screen. Every time a patient checks in, every screen needs to be updated. And they can't wait 5 minutes or 10 minutes, because everybody needs to know that that patient has checked in. When they're seated, they move them to the back in the clinic and put them in the seat to be worked on. They get done with their work, and got a new patient, they have to go to a consult room and be consulted on how much they're going to be charged for this new braces that they're going to get. Usually sit down with the parents. They get done, they check out. Those are real time. They have to be done now, because the person who's going to talk to the consult in the consult needs to know that she needs to go in the consult room. Can't wait. Otherwise, they're also keeping track of how long it takes for the person to get in the office and get out, because that's important to the patient, that they don't sit there and wait. So the orthodontist is tracking all of that information, and so this all gets updated. Less important, less timely is a patient calls and cancels or reschedules an appointment. Okay, the last 2 items here. So what this looks like, if you look at this window here, this is what we call the today schedule. Basically, it's the schedule for today. It doesn't matter what it says. It's just to give you an example of what they're seeing. The upper part of the window is the schedule for the day, and it just shows every appointment in a list. This is on pretty much everybody's desktop. Everybody has this up. This over here is just a representation of this, and that's being displayed on a wall in a large screen. And it updates as the day goes on, graying out, but it also updates as they check in and move across. The times change and show the check that they checked in. So this needs to be updated every time somebody has one of those actions. This here is what we call a daily schedule, and by clicking in the days of the month or over here, you change the schedule to that day, and all the information is there. You can also do make appointments in either of these 2 windows. Anyways, that's not why we're here, is to really see what. But you can see the problem. 7 computers, each with as many as 2 of these windows up. All of them need to be updated in real time, quickly. How did I do it in the past? Well, I've tried several different ways. I don't even remember how I've done it in the other ways. I do know that it causes a lot of traffic. You're either going to save a time last saved to the database and check a field in the database. I think the latest version before I've gone to this is to query the server. And the server, every time the table is updated, and it's only one table in this case, the appointment table, every time it's updated, it stores the time and date of that update. And then these clients query the server to see when the last update was. And if there's been an update between its last check and now, it refreshes the screen. Basically how it works. So you see this right here. This is basically what's right here and right here. They can set that refresh rate between 0 and 50 seconds. Now, how long should they set it? The guys in the back tend to set it at 2 seconds. Okay? The person in the front who's always working this window might set it at 30 or 50. Every time there's a refresh, remember, this window is going to do a move. So if you're working on something, something's going to happen in the background. It's distracting. So I give them the opportunity. 7 computers, many of them checking 2 seconds at a time. You can imagine the traffic that's going back and forth between the servers. So the challenge here, I thought, OK, call worker. Maybe I can make it work with call worker. So I sat down and laid out a plan. First thing I said, OK, I got to have the call worker working on the server. So I said, that's what I'm going to do, make the call worker work on the server. Now I got to have each client window on each client machine that needs to know about the update tell the worker that it needs to know. So what's it going to do? It's going to subscribe. Has anybody ever seen David Adams' presentation on 4D method about publish and subscribe using workers? This is stolen from him. Okay? Basically, we're going to subscribe each of these windows to a table. You can subscribe to as many tables as the window needs. Each window can subscribe up to as many. It's unlimited. So I have all 4 windows subscribing to table A. So basically, the worker records the subscriptions and knows who's waiting for an update. So let's say an update's done. Client 1, Client 1 changes a record or adds a record or deletes a record from table A. What happens when that happens? Anybody tell me? A trigger fires. Okay? Where's the trigger fired? On the server. That's cool. That's where the worker is. Okay? So all the trigger has to do is call the worker. Calls the worker and passes as much information as you think, as the programmer, the client needs to know. So the trigger can pass, the table number, any fields that needs to be known about can all be passed to the worker. So what does the worker do? The worker has to somehow tell the clients. The only way the worker can talk to the clients is with an execute on client. So an execute on client is issued when it gets a trigger call, and the method used for the execute on client performs a call form. And there's a method related to that call form which is different for every window or maybe the same for every window. Okay? And with that call form, the method runs and each window is updated. So now we've cut down the multiple thousands of calls per second to only when something's updated.
So you went from polling to pushing.
Right, right. And this is all possible because of call worker. Because remember, call worker, when it's finished doing what it does not die. And all the parameters or all the variables and whatever you have in that worker don't go away. So these subscriptions are retained by the worker. That's key to what a worker is and why it is important in our language. Okay? Okay, so this basically is the structure that I just showed you in steps, basically the same thing. What I want to do now is do a quick demo of it working before we jump into the code. Okay. see if I can stop this. This is the hardest part of the demo. Trying to figure out where I'm going. Okay. Okay, I got a 4D server running, and I got 4 windows, 4 different processes, as you can see, the black there. Okay, those are 4 processes running. I wanted to do it with client server and with a Windows in a VM, and I just couldn't get it to work after I got here. It worked so well at home, but I couldn't get it to work here. So it's fine. Everything works as fast as you're going to see here today. Okay? So here we are. We've got 4 windows. Okay, we've got this window, this window, this window, and this window. And there's buttons on here which are the commands, what has to be executed to get all this to work. The first thing that has to happen is we have to start the worker. Okay? Now, starting the worker could be done at any number of places in your code. It could start the worker when the server starts. You could start the worker with a button someplace. Or, as I have elected to do, I start the worker in the real database whenever a window opens and needs to do the monitoring. So every window that opens that needs to do monitoring will try to start the worker. If the worker's already running, nothing happens. It goes in and it just falls out. If the worker isn't running, it starts. So the first window opens starts the worker. That's the way I'm doing it. But you could have the worker already started at the beginning. Okay, so we're going to start the worker by clicking this button. I don't know if you heard the beep. I put a beep in whenever the worker runs. Okay, so whenever you hear the beep in the demo, that's the worker running. Okay, the next step is in the diagram is we need to subscribe each of these windows, and this is a call to a call server from the method here. Okay, and the subscribe is done. I need to subscribe each of these windows. Okay, now we're subscribed. Now the next thing I need to do, what happens is we need to have an event. We need to have a table changed. So I'm going to move this window over here. Is everybody seeing this okay? Okay, good. Okay, I'm going to take this middle window, this middle record, and just change it to okay. Now what's going to happen when I click this save button? Trigger's going to run. When the trigger runs, it's going to call the worker, and the worker is going to look to see who's subscribed to this table and update all of those windows. And all it's doing, as you'll see later, it's actually unpacking a C object to fill that. Okay? It's that simple. It's okay. And the code is very simple, as you'll see in a minute. It's not simple, but it's the actual code that does this is very small. But you'll see in a minute that I took a different approach than most of you probably would have taken. I'm going to do a delete just to show you that that works. Okay. Now, what it passed back this time was the event, deleted record, the monitor, and the information that it needs. That's the object that we're going to pass around in a minute, as you'll see. Everybody follow me? Okay. Let's get back to the... Okay, that's what we just looked at. All right. So, actually, I want to back this up. So here's the deal. So I sat down and I started to write the code, started to write a bunch of methods, and then I realized, you know what? Only need one method for all of this. Now I like that. I like to put all my stuff in a single method as much as I can. I don't like methods all over the place. You may have a different programming style, but at least you'll see in a minute that you can use one method and then you can call other methods from that method. But the structure of all of this only needs to be one method. One method that is run on the server and on the client. It's the same method, okay? It all depends on the context of of that method, how it's called, where is it called from, that determines what happens. Now that's what it looks like, all collapsed. Context means what's the environment that it's in when it gets called. If it's client-server, there's only 3 contexts that it can be called in. It can be called in 4D remote, meaning it's being called on the client. Or it could be called on the server, and there's 2 possibilities on the server. There's in a worker process or not in a worker process. Okay, you'll see all this in a second. In standalone, and this all works in standalone, and by the way, this method is available on your thumb drive. You just plug it into your program and it'll work. You don't need to do anything to it, it just works. Okay, in standalone, the only possibility is it's either in a worker process or it's not in a worker process, because there is no 4D remote. Okay, all of the communication, all of the parameters passed are all done with a C object, one C object. And there's 6 possible actions in each C. Every C object has an action property. Every C object that's passed has an action property, and there's 6 possibilities there. And those are the 6 things that include the 3 things that we just did, plus 2 more. So startup, we click the startup button. Subscribe, we click the subscribe button. Unsubscribe, we didn't see. If you want to unsubscribe it, there's a button there on that window to do that. There's also kill, which kills the worker, trigger, and then an important one, the call form, to make the call back to the client. Okay, how big is that? Does that look good? You can see that. Is it readable? Okay. This is the call object that I'm calling it a caller object. It's basically passes $1, and I'm just going to copy it into a local variable. This line of code here tells me, only using the origin part of it, it tells me whether it's a worker process or not. There's a constant that you can test, which you'll see in a second, that tells you it's a worker process. So that's how you can tell whether you're in a worker process or not in a worker process. So the first line of this case statement, it's testing, it got the action startup, and the application type is 4D remote, so our context is 4D client. It is a client method. We're in 4D client, it's a client method, and what's it going to do? It's going to execute on server and pass the same action to the server in the execute on server method. Okay, now the same, and what did it use to call? It used this method, the same method. So this comes in now on the server on this method. It's not in 4D remote mode, so it drops to the next one. Now the table monitor, we're trying to start up, right? So the table monitor is not working. So we have to check it if the process is working. So we check by checking the name of the worker, if it's with process number, and see if it's got any numbers there. If it's 0, it means it's not started yet. So it is an execute on server method, and what is it going to do? It's going to call the worker with the same action of startup, excuse me. And it used the same method for the worker method. So it falls through this worker method again. Startup is the action. And this time, we're going to check origin. Origin says it's a worker process. Therefore, we're in the worker, and the worker starts. And so it is the worker method. What's it going to do? It's going to start up and initialize the worker. We'll show you the initialization in a minute. Just go quickly through the subscribe. It's the same thing. 3 possible hits in here. The context, when we hit the subscribe button, we're on the remote client. So our context is 4D client. It is a client method, and what's it going to do? It's going to execute on server. It's going to use this method for the execute on server method. And when it falls through this time, it's going to fall down to that it's not a worker process. So but it is an execute on server method, and what's it going to do? It has to call the worker with a subscribe action. So it calls the worker with a subscribe action, The context is for the server, again, in a worker process. It is a worker method, and it subscribes the client. You can guess what happens next. Same thing for unsubscribe. Pretty straightforward. Context for the client, it is a client method. It executes on server. Comes down again, context, same thing. Executes on server method. This time it needs to call worker to tell it to unsubscribe, and so forth. Kill's a little different, only in that when it gets to the second line when it's on the server, but it's not in a worker, it just needs to kill the process. So we don't have to call the worker this time. It just kills the process. Trigger. We're in 4D server. Now, how did it get here? It is a worker method, and it got here because the trigger called it. And it called it with the action trigger. And so what does it do? It executes on client and calls the form, which in turn calls the form. Using the same method is called in the execute on client. And here, context is 4D client. We're not in a worker process. We have a call form as the action. It executes. It is the execute on client method, and all it does is call the form. Does everybody follow that? So with using one method, and it's easy for me to give it to you that way. It's one method. You just drop it into your database. Okay, so let's go through this a little bit deeper. Hope I don't put you to sleep now. This is the code part. Okay, so when I click the start worker, this is the code that's running behind that button. It's simply calling the method, or I'm going to call it the magic method, okay? Calling my magic method and creating a new object. Now we're using the new object, C object, and this is one of the neat things about the way we use new object now. There's no need to initialize that. You don't have to do C object something. You can just inline create the object as a parameter to the next method. I hope you're all aware of that. So all I'm doing here is giving it one property action and saying startup. Doesn't need to know any more. So here's how this works. This is the call the button that we just pushed. Drops into the method table update monitor worker. The first line here it's in 4D remote mode, so this has got to be where, and the action is startup. So at this point, it checks to see if the worker is already running. If it's running, it doesn't need to do anything, and it falls out. If it isn't running, then we're going to do an execute on server. And the interesting thing here is, again, because we're passing a C object, you don't need to do anything but pass the object that it was just passed, because there's no more information that the worker needs. It just needs to know I need to start up. So we just put that in as the parameter for that execute on server. Okay, so what happens? This method is going to be called on the server, because that's the method that we used for the execute on server. Gets called on server, and this time when it falls through, it's not on remote. It's still got the action startup. The table monitor isn't running, and so we're going to just do a call worker. And this time, we're calling the worker and using the same method for the worker method. As a side note, note that we're using this method as the call worker method. In later calls, you'll see this blank. That's because you have a choice. You can actually use a different method every time you call the worker if you want. But if you leave it blank, it uses the method that created the worker in the first place. So you can just leave it blank. So that's what you'll see as we go forward. And again, we just pass the passed object. We're just going to hand it off to the next call. So now it drops down. It's not remote. The table monitor is running now. The origin is worker process. And it drops into here. Now, here's where we initialize the subscription arrays, okay? I'm going to go more into the array, the initialization process a little down the road. But basically, there's 5 arrays that are populated that keep track of who's subscribing to what table. Okay, here's when I click subscribe. This is the code that's behind this button, subscribe. So again, we're calling the same method, the magic method, and we're passing a C object with the action of subscribe. Okay, a quick note on the client ID. The client ID is basically the registration name. Everybody know what I'm talking about? When you may be registering your clients up front. You may be needing a client registration for other purposes, okay? If you're not, the magic method will register your client for you. So you don't need to worry about that. But if you are, you need to pass the registration name of the client that's subscribing in this property, excuse me. If you pass a blank string in the property, table update monitor worker, the magic method, will register the client and keep track of that registration. Okay? So that's key here in this. Don't want to step on your registrations. That's why I did it that way. Okay? It needs to pass the window ID of the form that's wanting the response. It needs to pass the table that it wants to get the information back on, and that's done by passing the table number. And it needs to pass the method to use on the call form coming back. Could be anything you write. So that's your code. You write that method to do whatever needs to be done on that table. In my case, all I do is refresh the window. And that refreshes all of the appointments. And that's the method there. And we're calling the magic method. So again, this is the button we just pushed. It falls in, it's remote, and we're asking to subscribe. Now, don't throw rocks, anybody at me, that's global variable. I don't know of any way, if I'm going to register your client, I don't know of any way to keep track of that registration on the client, because I don't know of any way to programmatically get the registration client name. If anybody can show me that, I'd appreciate it. This may, however, be a good spot for the, what are they called, storage. This is a good spot for storage that's in the whole deal. I didn't know about storage until today, or I would have done it, okay? But this is where I'm going to store the registration name so that we can get it back later. It could be stored in the database, I guess, but then you would have to store all the other information along with it for the client and the window. Okay.
Get registered user doesn't work.
It gives you a list, but doesn't tell you who you are. That's the important thing. It needs to know, who am I? And there's no way to get that.
You have to name yourself.
Yeah, you have to keep track of it yourself. So anyways, so if it comes in with a blank client ID, then I'm going to register you. And basically, I'd use a timestamp for the registration name, blop it into my global variable. The standard process to registering a client is to unregister it and then register it to make sure that you're clearing everything. And I register it with that timestamp. Then I take that timestamp and populate that parameter that or that property in the C object that you pass me blank. Now it's going to carry the registration name. If it came in blank and this global variable is also is not blank, then that means you've already registered your client, and another window is trying to come in and monitor something. So all I'm going to do here is populate the property of client ID with that registration name. If this was not blank, then it's already populated. And all I need to do is take the next step, which is to execute on server with the caller object. Again, using this method, the magic method, as the caller execute on server method. So what happens? It falls through the method again. We don't have to go all this other stuff. We get down here, we got subscribe. We're not in the worker process, so we still have another step to go, and that's a simple call worker using the name of the worker, or and then notice I mentioned that this is blank. That would be where your method goes, but don't need it because it's going to use what it was started up with, and we just simply pass the C object. And calls the worker. Now it falls through. We're in the worker process, so it falls all the way down here. The action is subscribe. Now the next thing I'm doing, I'm taking a concatenation of the client ID, the table number, and the window ID as a unique identifier for this subscription. Otherwise, that's how I can quickly find the subscription later on when I need to tell you anything. So that's what that client subscription ID is all about. And then what we do is we populate those arrays that I told you to initialize before. There's an array for the client ID. There's an array for the callback method that needs to be called when you do the call worker. There's an array for the callback window ID, which also the call form needs. There's an array for the table number. And there's the array for that subscription ID that I just created. Okay, so here we are with the record. And now we're going to update the record and click the Save button. So what's going to happen? The trigger's going to run. And this is the trigger. The only time I need to run this code is if the worker is actually working. Because if the worker isn't working, there's nobody subscribing to anything, so the trigger doesn't need to do anything outside of what else it does. So in this case, I'm checking to see if the table monitor is working. So I pulled it all out of the case statement. Instead of trying to manage it inside the case statement for a normal trigger, I pulled it down below. And I'm just checking, okay, is it working? Ah, it is. Somebody wants to know about some tables. It doesn't matter. You could set this up to test what table, I think. I haven't even tried that. But this is just saying if the worker is working, then I'm just going to tell the trigger or the worker that I was updated. If he doesn't care, then it doesn't matter. This is going to go through. But if he does care, he's going to do something about it. Okay? There are three possibilities, well, there's four, but there's three possibilities that we care about in a trigger, and that's a new record, an updated record, or a deleted record. Basically, the new record and an updated record are the same in this particular instance. We don't care about the difference, except that you may want to pass a bunch of information also along in the updated record, or even in the new record. It's up to you. So let's look. The deleted one is pretty simple and basically does a call worker, same method. It's going to use the same method, our magic method. Actually, it's calling the worker. It's not using a method. I'm sorry. Action is trigger, so it's setting the action. It's passing the table number, that what was deleted, what from what table, and the trigger event. So it was whatever the trigger event was. In this case, it's deleted. On saving a new record or updating a record, it's exactly the same thing, except beyond the three that the delete does, it's up to you to decide what you want to be passing along back to the client. In this case, all I did was pass back the comment field that I typed in. So that's the only thing. But you could pass as much information as needed for the client to know what to do. Okay, so here's that call worker that just got called. There's only one case statement with trigger in it, and that's this one. So it comes in. And what we're going to do here is basically do a while loop with a find in it to search for that client ID, to search for that table number. And every time it finds that table number, it knows that some window is wanting to know about that table and what happened. So if it's found and the client ID is blank, there's only one possibility. You're not on client server mode. The client ID has to be filled. So in this case, the worker is running on the client, so all we need to do at this point is call the form. We're already on the same machine with the form that asked for it. So we call the form. This is the form method that you create. All I did was take and put in that field that showed the update, I stringified the C object. That's all I'm doing. Okay. However, if the client ID isn't blank, then we need to call the form on the server. And the action is call form. We're going to pass the method that the client initially said, this is the method I want you to run when you talk to me, when you come back to me. And the window ID, this is my window ID. That was passed. That was all stored earlier. And we're going to execute on client using the client ID, the registration name. That gets us back to the client. That's why we had to register the client. And using the same method to execute on the client, we pass the C object. And as you can see, the C object runs. The call form now is the action. It's the only one in the case statement. The call form then calls using the window ID and the method and passes the object. And then your method runs. That's it. Does that make any sense? Did I lose anybody? Okay, I went pretty quick, actually. I'll get you out of here early. Question?
So without the call worker call form, you could do this basically the same way, but instead of worrying about the client ID from the client side, you just do a call process -1 and you hit all the windows on each client. And you just cycle through the clients and they all get updated when a change occurs.
But then you're updating all of them.
You're updating all the clients, but
But that's not what I want. I want to update those who are asking to be updated.
Okay.
And there may be windows that are only asking for this table, and another window is asking for this table. So there's no intelligence, and you're just saying, that's basically what I was doing before. It does cut down the number of hits, but it's basically doing the same thing as before. If there was an update, everybody updates. But it doesn't need to do that. That answer the question? Yeah. Question in the back.
Yeah, you mentioned that when your form method, all you're doing is refreshing the screen.
Yeah.
So you're getting that event, and you're just going back and hitting the database again and refreshing the whole screen is how you've done it. Did you put it, I guess, if you're passing more information back?
Yeah, I know your question. Yeah.
What are the pros and cons there?
Yeah, you know, there's a matter of time that's involved in doing any of this, and you're going to give your client the update. The quickest way to give them the update is do the least amount of work, because this was an issue that we wanted to resolve, this constant timing. So the easiest way was to retain the old method of just refreshing the whole screen. The plan is to pass more information and I could be passing information like the date and time. If we're not displaying that date and time, why do I have to update the screen? So you pass back the date and time, then the client method would check, oh, I'm not displaying that, I'm not doing anything, I'm not going to refresh. So it knows not to do anything. It could also pass back what field got changed in the modification. And I can say, okay, we're not even looking, in some of those windows, you're only looking at a certain appointment. You don't need to change anything, okay? So yes, you're absolutely right. There's a lot more that could be done here to make it even more efficient. But right now, to get it quick to the client, I'm just refreshing the screen, which is what was being done before. Another question. Chuck?
So, two things.
Wait. Yeah, sorry.
I'm sorry. What happens if you're in a transaction? So I'm in client one in a transaction, so you can refresh the screen all you want.
Why would you want to be in a
transaction?
transaction? No.
I'm sorry?
I said, like Roland would say, why would you want to be in a transaction? No.
Because all 4D programmers put them
Do I
in
know?
transactions.
What happens if you're in a transaction on the client?
Yeah. And I call your worker and I do an.
Well, actually, what happens if you're in a transaction on the client? You can't do an update to the record until that transaction is done anyways.
No, you're missing the point. I'm the worker, right? I'm the client that's making the change, right? I'm the client that makes the change. I'm in the, right? I go and I save the record. So that trigger runs, okay? The save event record runs, okay? And then you're going to call the worker to update all other people who may have that particular record loaded, but they can't get at it anyway until I validate my transaction.
Actually, oh, they're not going to see it until that's validated.
That's right.
But why? But I wouldn't have a transaction on the server going.
It's not a transaction on the server, it's a transaction on the client. But the trigger is happening on the server. It's still inside of a
Yeah.
transaction.
The trigger has to, yeah, the transaction has to be validated before the trigger runs. That's right. The trigger's not going to run until the transaction is validated. Yeah, that's when the file is updated.
Okay, I didn't realize that, but
Okay, you had a second. Yeah, I got. Okay, got a question over here.
Well, it's not necessarily a question, but it's a comment. The call form is a super, super useful command that we never had before, because you can just tell one window, run this method, not past the -1, you know, to update all the IP variables on all of them, or set timer or anything like that. It's super efficient. And so when you went through all of this, I was thinking, is there any way you can make it any more efficient over the network? And I really can't see much, because you're only doing just what you need to do each time. You are executing a process on the server. Execute on the server, so each
But
time...
it runs really quick. I mean, it's,
Yeah.
it's just.
So each time this happens, you're starting a process on the server, which does a little thing and moves on. I wondered if you had just set the execute on server property in a method. That would cause that method to
Yeah.
run on the server.
That would work, I
And it
think.
wouldn't have to start a new process.
Yeah.
It might even get the same effect, and maybe you'd get a couple of milliseconds.
Yeah, that's
you
a
know,
little more
maybe.
efficient.
But this is super efficient from polling continuously.
Right.
Waiting and polling. Now you just push, when something happens, you just push it off and execute on client. You get back the other direction.
Get you the other direction. The call form is very efficient, and it's good for that. And one thing I realized also, the worker, doing a call worker and using a worker, doesn't have to be for something big like this. I can't remember exactly what I used it for, but I used a worker to keep track of something that I couldn't keep track of without a global variable like this. And I was able to use a call worker to temporarily store something and get it back by another client. And it worked, not another client, another process. Between processes, I could call that worker and get the information that I needed. For little things, you can just start up a worker. It doesn't take up much room.
And there's no semaphores involved in any of these things?
No semaphores.
And you got an automatic queue with the worker.
Yeah.
So you could have 15 clients send at the exact same time. You're never going to lose any of the messages. They're just going to stack up and
Right.
run in order. If
That's
order
a
matters.
very good point, because in my other process, the way I was running it, I did run into issues where a client would query to find out if there was any changes, and the process was busy. So what happens to that query? It's lost. It's just gone. In this situation, the worker has it stacked. So as soon as it gets done with this one, it takes the next one, it takes the next one, it takes the next one. You never lose anybody asking or anything, and if nothing ever gets lost. Is that it? Okay, thank you.